Hello, I'm Dr. Harper. This video is in Supply Chain Analytics, a Logistics Homework Excel tutorial, Company C, Part 2. So let's bring up the problem. Now in this problem, Logistics Company C ships weekly from 2 agricultural suppliers to 3 regional warehouses, which distribute to 3 local retailers. Each warehouse distributes to only 1 retailer, but a warehouse has the option to ship to another warehouse instead of a retailer if needed. And there's the difference between Part 1 and Part 2. The warehouses transfer inventory immediately from inbound to outbound and thus carry no inventory. The weekly supply, weekly demand, and unit costs are given in the tables. So it's a little different problem than Part 1, but it's similar. But we're adding that you can ship between warehouses now at the same level of the supply chain. Okay, so let's solve this thing. So let's bring up Excel. First of all, to set up Excel, let's remember we have 3 legs now. 3 legs to the distribution, from the supplier to the warehouse, from the warehouse to the warehouse, and then the warehouse to the retailer. So first, let's set it up. First, let's take the shipping cost here, Control C. Let's bring Excel back. Here we have come down a ways. Control V and paste this thing. Okay, let's open this up. Let's open this up, and then let's format the rows, and then let's format the columns. There we go. Okay. Oops, didn't format. Come over here we go. Now we format these. There they are. Okay, now here's our from our supplier to the warehouse, and then we don't need all this too. Let's see here. Let's enlarge this. Let's just say warehouse 1, warehouse 2, warehouse 3, and supplier 1, and supplier 2. Okay, there we go. Now, then we have the weekly supply here, and this is going to be our supply. That's going to be 300 and 400. I'll just type that in, and so that's good. So that's the first leg. It goes from the supplier to the warehouse. So there's our unit costs. Okay, so let's no border, and then let's boom. Let's do this. Start formatting this thing. So that's the first leg. Okay. Then we have the second leg, and that's going to be from the bring the warehouses down. There we go. And then this is going to be, do it again. This is going to be from warehouse 1 to warehouse 2 to warehouse 3. This is going to be the cost. Oops, COST, unit cost between warehouse and warehouse. Now from warehouse 1 to warehouse 1, it's 0. But then here is where we're going to take these values here. Let's bring this up here. Bring this over a little bit. Bring Excel back. Okay, and then we start filling these in. Warehouse 1 to 2 and 1 to 3 is 2 and 3. Okay, well, we know that from 2 to 2 is 0, and from 3 to 3 is 0. You don't ship to yourself. Okay, now the next here is from right here, from 2 to 1 and 2 to 3. Let's bring Excel back. Okay, 2 to 1 we see here is 3. And then 2 to 3 is 2. Okay, and then we bring this down a little bit more to where we have 3 to 1. 3 to 1 is 2. And 3 to 2 is 3. So there are those costs. Okay, let's enlarge this. And these are costs. Let's go ahead and make these into costs, into currency. And we don't need the zeros. Okay, so now we have that. And then that's the second leg. And then the third leg is from the unit costs here. Bring it down here a ways. This one is to the retailer. Okay, and this is to the retailers. And this is going to be, let's take these and copy these, just so we don't have to put them here. Paste. And this is going to be retailer 2 and retailer 3. There we go. Okay. So we have these costs here. We can box these in. And then we'll have these costs here. We'll box these in. Okay, now in the retailer, let's bring this over. Bring this over. And boom, there they are. Okay, let's bring this up. So warehouse 1 to retailer 1 is 27. 27. Warehouse 2 to retailer 2 is 28. 28. And then 25. Now these others, warehouse 1 only ships to retailer 1, and that's all. It doesn't ship to anything else. Okay, so in order to prevent warehouse 1 from shipping to retailer 2 and retailer 3, let's just make the values very, very large. 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. So I could have had a constraint and say those are 0, or I'll just put a very high cost in there. If you're minimizing cost, you're not going to ship there. And that's just kind of like a probably easy way to do it, just typing that in instead of having 1, 2, 3, 6 different constraints saying that should be 0. Okay, and then finally we have our demand up here. Right, there's our retailer demand. Okay, and let's just take these, Control C, and put them right in here. And this is our demand. Okay, so now that we have everything set up and everything is there, and there they are. Okay, now let's, no border, let's bring this back to a box. There we go. So now we have everything, put a box there. We have everything set up. Now we solve it. Now remember, we have one leg here, one leg here, one leg here. So let's do it over here. So this is the definition. Now over here is going to be the solution. Okay. Okay, this is going to be, first of all, the schedule. And this is going to be warehouse 1, 2, and 3. And this is going to be supplier 1 and supplier 2. Okay, so this is going to be the outbound. I could say production, I could say supply, but that's what supplier 1 and 2 is going to be shipping. Okay, and so this right, actually let's make these, bring these down, no border, just box this in. So this is what the outbound is. That's going to be the sum of everything that supplier 1 ships right there and supplier 2 ships, and this is the inbound. Whoops, this is the warehouses. No, don't know where those came from. There we go. Oops. Okay, so then the inbound to warehouse 1 and 2 is just the sum of these, of each of these. Copy this over. Okay. Now, to make sure that this is correct, let's just all 3, all 2, all 2. Good. Now this right here, let's darken this. This would be the cost. This would be the sum product of the unit costs in this leg of the transport, comma, the actual shipping schedule. So whatever you ship times the unit cost, that's the cost on the first leg. And there we go. Let's bring that down. Okay, so there's the first leg. And actually, let's shade this in because that is going to be, this is our schedule. That's our decision variables. Okay, now the second leg. The second leg down here, that's going to be from warehouse to warehouse. Okay, and then this would be a schedule again, but this time it's from warehouse to warehouse. So we have this warehouse up here and this warehouse over here. And there they are. Again, format them to keep them all under control. Let's box this in and let's shade that because that is going to be the second schedule that we'll be looking at. Okay, again, we have the outbound, which is the sum of everything that warehouse 1 ships to warehouse 1, 2, and 3. Copy this down. That's the outbound of warehouse 1. And this is the inbound of warehouse 1. It's the sum of everything from warehouse 1, 2, and 3. Copy that over. And let's make sure that these are right. We get all 3, all 3, all 3. This is all 2, all 3, all 3, all 3. Good. And let's box this in, and this will be the sum product of, again, the unit costs here, comma, the shipping schedule. There we go. That's the second leg. Okay, now let's go to the third leg. Okay, and this is from the warehouse to the retailers. And this will be the schedule. Now, we will have the retailers up here, retailer 1, 2, and 3. And we have the warehouses down here, 1, 2, and 3. Okay, and let's box this in, shaded, because this will be our third set of decision variables that we want to change. Again, we have an outbound that warehouse 1, 2, and 3 is going to be shipping out of. Retailer 1, 2, and 3. Copy this down. Okay, and this is the inbound. Actually, let's say received. This is what our retailers will receive. Equals the sum of everything from 1, 2, and 3. Copy this over. Boom, boom, boom. Let's make sure that this is right. All 3, all 3. That's correct. Okay. Okay. And there we go. Again, let's box this in. Let's say the sum product of the unit shipping costs here, comma, the schedule. Sum product of those two, and then we add it up. Let's make sure that we did do it right. And sure enough, blue times red, and there we go. Okay, there we go. Okay, and then down here, we have the total shipping cost equals, let's right justify this, this will equal this plus this plus that. And boom, that's the total shipping cost. That's going to be everything. Just sum those three. This plus this plus this. The cost of the first leg, cost of the second leg, cost of the third leg. That's the total shipping cost. That's what we want to minimize. Okay. So let's do it. Now that we have it set up, everything is good to go. Let's do it. Okay. So let's reduce this a little bit so we can kind of see everything. Come to data, come to solver. Okay. Okay. The single cell here, let's just reset it all. It's kind of getting, okay. Our objective function is this. We want to minimize it by changing, we want to change these, comma, we want to change these, comma, we want to change these. So we have three sets of variables we're changing. Now we start adding our constraint set. So the first constraint set is the outbound from the supplier is less than or equal to the supply that it has to deliver. It doesn't have to ship everything, but it can't ship more than what it has. Good. That's the first one. Add. Now, the inbound from warehouse 1, 2, and 3 is going to be equal to the outbound of 1, 2, and 3. Because what it receives is shipping out. Because it carries no inventory. Okay. And then we add. Okay. Now, the inbound of the warehouses is going to equal the outbound of the warehouses to the retailer. Again, they carry no inventory. Now we add again. What is received from the retailer must be, I could say equal to, let me say greater than or equal to the demand over here. Okay, I say okay. And non-activity constraints, simplex algorithm. And so when I solve this thing, I see that I have solver found a solution. All constraints and optimality conditions are satisfied. Yep, I'll save that. And so there's this is the cost. So there's our shipping schedule on the first leg and the cost of the first leg. Shipping schedule on the second leg, the cost of the second leg, which is not very much at all. But then the shipping schedule on the third leg, and there's a cost. Notice most of it is the third leg because the unit costs are so high. And notice right here, we have warehouse 1 receives from 1 and 3. And here, even though the inbound is 200, only receives 150. And so it minimizes the cost here of 20,000. We can come to the data here and say, I tell you what, let's just make it dollars because that's exactly what it is. Okay, $20,100. And so there's our shipping schedule, and there's our total cost. Okay, so that's really all I have for this problem, part C. I hope this helps. Between now and the next time I see you, I want to urge everyone to be safe and take care.